Good evening, everyone. My name is Raplang Umdor. I'm going to present a work which is the adsorption of ciprofloxacin antibiotic by magnesium aluminum activated carbon composite. We will also discuss regarding the kinetic, isotherm, and kinetic and thermodynamic study. Now, we know that pharmaceutical industries are growing all over the world. So here in our work, what we're trying to do is that we're trying to remove this antibiotic ciprofloxacin, because this antibiotic ciprofloxacin, when present in wastewater, they lead to the development and spread of antibiotic-resistant bacteria. So for this purpose, we are going to use an adsorbent known as magnesium aluminum LDH, which composite with activated carbon. Now, the layer double hydroxide is nothing but it's a 2D material which consists of a divalent and trivalent cations, and in the interlayer spaces, it consists of water molecules and anions. But the disadvantage of these layer double hydroxide is that it can undergo aggregation. It has very low surface area and limited functional groups. So for this reason, we use a support material known as activated carbon because of their large surface area, abundant pores, and wide variety of functional groups on the surface. So for the synthesis of this composite, we use the co-precipitation method. First of all, we synthesize the activated carbon from a locally available biomass. And then after that, we take the activated carbon, disperse in deionized water, and then we add the mixture of the metal salts. And then we maintain the pH of the solution to 10 by adding an alkaline solution, sodium hydroxide and sodium carbonate. Next, we have the characterization. If you look at the XRE peak, we see that the pure LDH, magnesium aluminum LDH, show a typical peak of any LDH. So of the magnesium aluminum LDH. Now in this work, what we have done is that we have added a various dosage of activated carbon. And then after adding various dosage of activated carbon, we see that the peaks remain the same, but then the intensity decreases. So this could be due to the presence of the activated carbon, which reduces the crystallinity of the composite. Now, the bed surface area showed that after adding activated carbon, the surface area has increased increased a lot. So from the surface area of the pure magnesium aluminum is 73.05 meters square per gram, whereas the composite is 568.87 meters square per gram. Now, the FTIR tells us about the functional groups. So we see that there's an hydroxyl group, which could be due to the water in the interlayer anion. We have the carbonate also, which could be the anion present in the interlayer anion. And then we have the metal oxygen bond, which can be magnesium oxygen or magnesium aluminum, and the magnesium hydroxide stretching. Now, if you look at the SEM composite, we see that for the pure LDH, we see that there's irregular plate-like structures stacked one above the other. But when we look at the composite of the magnesium aluminum activated carbon, we see that the LDH is actually dispersed on the surface of the activated carbon, also occupying the pores of the activated carbon. Now, for our next work, we conducted an adsorption study, trying to find the optimum conditions of the dosage, concentration, time, and pH. Now we see that the dosage we got as 0.06, concentration 100 ppm, time 160 minutes, and pH 9. Now at pH 9, we know that ciprofloxacin has two pKa value, one is 6.1 and 8.7, meaning that below 6.1, it exists as a cation. Between 6.1 and 8.7, it exists as an Zwitter ionic, and then above 8.7, it exists as an anion. Whereas the 0 point charge of the composite was found to be 9.3. So meaning that below 9.3, it exists as a cation, and above 9.3, it exists as an anion. So at pH 9, the ciprofloxacin exists as an anion, whereas the composite exists as a cation. So therefore, the interaction between them could possibly due to the electrostatic interaction. Next, these data were then fitted into the different isotherm and kinetic models. So for the isotherm studies, we got the Redlich-Peterson as the best fitted model with an R-square value of 0.996. Whereas for the kinetic studies, the best fitted model was the pseudo second order with an R-square value of 0.990. Now, the thermodynamic study shows us that the delta G is a negative value, indicating that the adsorption process is spontaneous. And delta H is also a negative value, meaning that the adsorption process is exothermic. And delta S, the entropy, is positive, meaning that in the interlayer spaces of the adsorbate and adsorbent, the disorder increases. So in conclusion, The magnesium aluminum composite was synthesized by using post-pyrolysis co-precipitation method. The bed surface analysis showed that the increase in the surface area of the composite as compared to the pristine LDH. The batch adsorption study gave us the optimum condition. The pH study indicated that the electrostatic interaction was responsible for the adsorption process. The best fitted isotherm model was the Redlich-Peterson, whereas for the kinetic, it was the pseudo-second order. And the thermodynamic study showed that the adsorption process is spontaneous, favorable, and exothermic in nature. Thank you very much.
Sir, myself is Dhruv Kumar, paper ID is 203. Topic is recent advances in fabrication, characterization, and wear behavior of aluminum metal matrix composite. I am the research scholar from Amity University, Greater Noida. Sir, basically, you know that aluminum alloy basically have some alloying element. The combination of these alloying element are copper, zinc, magnesium, and manganese are among the metal that are basically alloyed to the aluminum to increase the mechanical strength and for some particular specific usage. So basically, aluminum alloy is a low density and have good electrical and thermal conductivity, improve resistance to oxidation and corrosion resistance, and basically the main advantage is it is inexpensive. Aluminum alloy basically commonly utilizes lightweight material, and numerous have the applications such as aerospace engineering, automobile, and power electronics sector, where a lightweight material is needed. So my main focus is on the aluminum alloy 6061. So aluminum alloy 6061 is basically heat treated aluminum alloy, which have special attention in the automotive and aviation industry. Aluminum 6000 basically series aluminum alloy have two major constituent element. One is the magnesium and other is the silicon. So these are the basically constituents of the aluminum alloy 6061. Magnesium basically contain 0.8 to 1.2%, silicon 0.4 to 0.8%, iron is 0.7%, copper is 0.15 to 4%, 0.4%, zinc, lead is 0.25, manganese is 0.15, titanium is 0.15, and chromium is 0.04 to 0.4, and rest is balance is the aluminum. So if we'll talk about the physical property of the aluminum alloy 6061, basically it has tensile strength 115 megapascal, elastic modulus 70 to 8 megapascal, and Rockwell hardness number is 30 BHN. So basically, aluminum alloy 6061 have exceptional strength to weight ratio, improved formability, weldability, have the major drawback of basically have poor temperature resistance and weak in wear. So it is need to basically enhance the mechanical strength of the such type of material by reinforcing some other nano and microparticles. So a lot of reinforcing elements are available. These are basically carbide, such as boron carbide, silicon carbide, titanium carbide. Oxides are aluminum oxide, titanium oxide, and zirconium oxide. And some other carbon-based particles. Yes, sir.
Can you give the conclusion? I think in almost 10 minutes it's gone. Yeah. Please give the conclusion.
Various fabrication techniques are available, such as ester casting, spray casting, spray coating, ultrasonic, and other one is the solid ester processing techniques such as powder metallurgy method. In ester casting method, basically reinforcement material poured in the molten state, and various parameters are basically responsible for the influencing the microstructure of the composite, such as steering time, temperature, and steerer speed are the basically.
So good morning everyone, I am Dr. Subhashish Dey, and today I present my presentations on the topic of the PARTHENIUM biosolvent for the application for removal of fluoride and hardness from the water. So the presence of protein aqueous solution had the same methods are affecting the environment, and normally the groundwater contamination is one of the problem in this area. So we have to use this problem. The hardness is the various formed in the water, like gaseous form or liquid form. They are heated to the ice, the spirit test, and other problem also created. So this is also affecting the body, and these exposures we have to show in this research area. So we are using the one of the technology known as the biomaterials. This is the bioabsorption process. In this process, we are using the biological materials. These biological materials are highly effective for the removal of hardness and fluoride from the water in the cellular structures. So bioabsorption is a metabolic process, and this is requirement not energy. This is the kinetic equivalent conditions. It has a physical, chemical, and biological property for removal of heavy metals from the water. So this is the process, and the hardness is the one of the characteristics. It produces the leathering soap, and the hardness of water divided two parts: temporary hardness, permanent hardness. We are mainly working to the permanent hardness removed from the water. So this is the biomaterials we are using for removal of hardness from the water, like rice earth, rare stock, Parthenium biodominant, sawdust, and egg cells also. So this is the different biodominant prepared in the laboratory. We first wash this biomaterial and moisture free and high increasing temperature, and then put into the, after grinding it, put into the airtight container. So we have to do the collections, cleaning, drying, and grinding and storage of the of water, these biomaterials. So this is the process we collecting the biomaterials. After then washing, cleaning, then we have to forming the powder and leading to the water for removal of hardness from the water. So this is the synthetic water conical flask. We are using biomaterials, rotary seeker, and filtration process. We are adding the 20 ml biomaterial to the conical flask, and we have to measure the how much percentage of this hardness are removed from the water by the titration processes also. So this is the biomaterials, and this is the conical flask we are using for the removal of these biomaterials. After the application of the biomaterial to the conical flask, we have to mix secate to the for 2 hours, then filter the solutions, then measure how much percentage of hardness removed from the water. So in the result discussion percentage, the rice is highly effective for the removal of 20% removal at the 5 gram of the biosolvents. Second, the rest also effective for the 18% of removal of biosolvents for the 5 grams, and the other like the Parthenium is also capable for 50% removal of by this hardness from the water by this application of this biosolvent. Other like the sawdust is also capable for the 35% of removal by this application of 5 gram biosolvent. And last is the egg cell. This is also capable of removal of nearly 25% by this application of 5 gram biosolvent. This is a combination of graph. So in this graph, we have to see that the highest percentage of removal of hardness by the red straw, rices, the Excel and Parthenium. Parthenium shows the best activity 50% for the removal of hardness from the water. So this is the tabular form. We have to compare the graph and we have to measure the how much percentage effective for this activity of this biomaterial. So 5 gram of this doses of this Parthenium bioabsorbent. This is the 50% removal of the hardness from the waters. So then we have to measure the optimization process, the optimal pH conditions. First, we measure doses of bioabsorbent. So we have to getting 3.8 gram of bioabsorbent effective for the removal of 50% of the hardness from the water. Then we have to measure the optimum temperature. So temperature will vary from 20 degrees centigrade, so 10 degree to 50 degrees centigrade, and optimum temperature we are getting the 30 degrees centigrade. Then we're getting the pH value from 6.9 to 7.5, and the optimum pH we are getting nearly 7.5 to 8. And then we have to get the contact time between the biomaterial and water in the shaker. This is the nearly 80-minute contact time. Then the initial and low biomaterial removal process, the optimum rotation speed we have to get in the 80 RPM rotation speed. This is the optimization process for the removal of the Pyrolytic biosolvent by the using of the hardness removal from the water. So this is the maximum percentage removal we are getting the hardness removal is 50%. Biosolvent dosage is 3.9 gram, temperature 28 degrees centigrade, optimum pH is 7.2, contact time is 60 minutes, and ETS speed is the 80
Good
RPM.
evening, everyone. Myself, Dr. Konica Sharma from School of Basic and Applied Sciences, India's Vidyapeeth. My topic for the day is development of superhydrophobic surfaces on copper and brass as for corrosion resistance application, a comparative study. In the outline, I'll discuss introduction, corrosion and its impact, synthesis process, methodology, and characterization, and conclusion. Moving towards the first slide, that is corrosion and its impact. We know that the corrosion mechanism, we can classify in three sets like electrochemical, physiochemical, adhesion towards the surface, how the surface and the coating works. These are all the mechanisms we can apply for corrosion resistance. And although the impact of corrosion on the various industries, various areas, it impacts economy also. It impacts artifacts also. It impact environment also. So the contamination and loss of the products because of corrosion has a huge impact on the various industries of metal, alloys, infrastructure, engineering, even in defense also. So if we propose a coating, moreover, nowadays the coating has become a significant method to work on corrosion resistance for the various surfaces. Is even ceramics also, polymers also. So what we are doing is super hydrophobic surfaces. For that, we need to understand what are the different surfaces and how we can classify them. We classify various surfaces on the basis of the contact angle made by the water with the surface. If the contact angle is below 90 degree, then the surface becomes hydrophilic, and then comes the contact angle 90 degree or greater than 90 degree, then it becomes so hydrophobic. If the contact angle becomes greater than 150 degree, then it becomes super hydrophobic. And in nature also, super hydrophobic and hydrophobic surfaces exist, like pigeon feather. Here I'm showing a leaf where a droplet of water, have a contact angle greater than 90 degree and showing the less affinity towards the surface of leaf. So moving towards the synthesis process of this surfaces, is, there are two basic rules to synthesize the superhydrophobic surface: the water contact angle, surface roughness, or we can call it as modification of surface. Is what we do is in the nano roughness areas, the low water air contact, there should be a water contact with the surface should be minimized with the help of low surface energy materials diminish the adhesion between the surface. Here the picture shows that how it works. Like if we create a rough surface or a nano surface or micro or a hierarchical surface, hierarchical structure means the combination of micro and nano structure in which in which the air trapped among these grooves and the water and the surface contact becomes less, becomes less, and the angle increases between them because the spherical shape of the droplet becomes perfect because of less affinity towards the surface. So, various methods are being used for the synthesis of superhydrophobic surfaces: sol gel, electrodepositioning, chemical etching, dip coating, and so what we have done in the synthesis process is we used a silica silica for this synthesis process, and we have synthesized silica hydroxide with a low surface energy material, that is triethoxyoctylsilane. And after preparing the coating, we have prepared the surface, that is metal and alloy surface. Preparing surface means we have etched the surface to make it compatible for the coating, and then we dip that surface brass and copper in that synthesized coating and achieve the superhydrophobic surface as required according to the analysis. The coating we have synthesized or functionalized, it shows the FTIR shows it is being synthesized or functionalized properly, as the change in the peaks shows the CH bond and that alkyl groups, presence of alkyl group in the coating in due to triethoxyoctylsilane. Then XRD graph confirms the surface, the metal and alloy surface crystallinity is as it is. There is no major change in that. And then coming towards the AFM structure, because we need to measure the roughness of the surface to increase the roughness for coated brass us there is these are the parameters we have achieved, like even the average roughness and RMS roughness near about 25 nanometer for brass. So even the asperities here shows the roughness has been achieved for the coating in, over the metal surface and alloy surface. Then for copper, the same parameters of roughness and the AFM images shows the asperities have achieved for roughness, in which the air will be trapped easily. The grooves have been created. This is all the contact angle measurements, and so the average roughness we have achieved for uh, brass and copper is as shown, 22 for brass and 142 for copper, then 152 contact angle for brass and 155 for copper. Sliding angle is 5 and 4 for copper. Then the STEM images shows that the agglomeration is less, is, and the nanoparticles have been properly inserted, or what we can say is they have positioned, or a micro level and a nano level of structure what we want to achieve for the superhydrophobic structure has been revealed by the STEM images. Then as explained, the perfect spherical shape of water droplet we have achieved on both the surfaces, brass and copper. Little bit different of our contact angle, because we have achieved in brass we have achieved 152, and in copper we have achieved 155. So that's the only difference. So then, if talking about the corrosion resistance ability, the polarization curve, the shift in these curves shows that the efficiency, the corrosion efficiency of the metal and alloy has been enhanced. And the parameters that after the calculation, the efficiency, impedance efficiency of copper we have achieved is 67%, and for brass we have achieved is 46%. Then for copper and brass samples, an exquisite plot. The area under this curve shows, as if the area under the curve is large, then it means the corrosion efficiency is large. So the graph shows clearly that the area under the curve of coated copper increases. That means the impedance efficiency is large for both the samples, and for copper it's 67 and for brass it's 44 according to the calculations, and it is matching with the previous as EIS data. So the data is the results are relevant. So on concluding all the parameter, all the things, I would say that before synthesizing any superhydrophobic surface, a few parameters like wettability, surface energy, contact angle, and roughness need to be catered and taken into consideration. Then we have synthesized silica with functionalization process and the sol gel process over a metal and alloy surface. AFM SEM images reveal the micro nanohierarchical morphology of the coating. Then AIS plots and polarization curves reveals the impedance efficiency is near about 60 to 70 and 40 to 50 for brass. On comparing both the resistances, copper and brass, what I will add this in the whole paper also, that there are major things like corrosion in copper is generally, this is something in which is relatively low than brass, but due to presence of zinc and in brass and magnesium, such contents present in the brass, there is some discrepancy in their in the roughness values and in the sliding angle values in the contact angle values of copper and brass. Then efficiency is also changing. As for copper, it is near to 60 to 70% we have achieved, and for brass, is near about 40 to 50%. So all these parameters shows that there is a change, and these are the change reason behind this is the structure, maybe the structure also. Then roughness parameters, profile heights. The profile heights shown in the brass and copper are different, and those heights, trap more air and more the surface contact area decreases between the water and metal or alloy surfaces. That depends on also on that also. Then inhibition efficiency of brass is due to their alpha beta phase, in which zinc and the copper part is also there. So there are so many things we will discuss in the paper also. So this is all I have to conclude, and that's all from my side. Thank you.
So, good evening, everyone. Myself, Dr. Vanna Saxena. I am professor in Department of Applied Science and Humanities, IMT College of Engineering, Greater Noida. Slide is visible to everyone.
Yes,
Sir,
ma'am.
slide is visible to you.
Could you keep it
All
on
right.
the screen mode?
Okay, sir. So here I am presenting one of my research work, which is based on the adsorptive removal of fluoride ion using biochar, which is specifically developed from dried stem of agricultural biomass, which is Vigna mungo, a black gram, and then we modified it with the zirconium oxide, nano zirconium oxide, to enhance its adsorptive capacity. So before starting defining our research objective, let me give you a brief introduction about why we chose this topic and why the fluoride in drinking water has become so much concerning these days. So in drinking water, there was a time that fluoride was not considered as a toxic end, but it is required to maintain our healthy bones and teeth as well. Uh, in fact, its deficiency causes tooth decay and impairment in bone mineralization in growing children. But now, due to heavy pollution, the scenario has been changed, and now we are facing a toxicity in water bodies due to the fluoride contamination. And now we are facing the toxicity of fluoride, which resulted in the fluorosis, a condition that impacts the dental health, that is called dental fluorosis, and skeletal health, which causes the crippling of legs, which is called as skeletal fluorosis. So WHO has prescribed a guideline that gives the permissible limit between the range of 0.5 to 1 milligram per liter, that is 1.5 milligram per liter actually. So as you can see that there is a very narrow range between the desirable limit and permissible limit, as the desirable limit is up to 1 milligram per liter and permissible limit is 1.5 milligram per liter according to WHO. So due to this very narrow range, it is called as a double-edged sword. So due to its high toxicity in nature, in aqueous environment, has become very important to remediate this environmental issue. So the high concentration of fluoride, as I discussed, that it has possessed the very crucial impact on the human health. So there are so many methods that has been developed earlier to remediate water bodies, to defluoridate water bodies using the electrostatic method, precipitation method, oxidation method, and adsorption method, of course. So among all, the adsorption method is being very much suited method for the water remediation, and there are so many adsorbent has been already published. So why we chose this adsorbent based method? Because our target is to develop a cost effective, eco-friendly and sustainable material that can be provide a good option for to defluoridate water body. So as we can see that the metal functionalized adsorbent is well known in these days. Around various transition metal like titanium, iron, silver are being used to enhance the adsorptive capacity of that adsorbent. We chose zirconium because it is low cost, it has very less toxic impact on environment, and it does not transit its oxidation state to a toxic level. So therefore it is eco-friendly, and it does not harm any bad impact on human health. So our objective is to develop a zirconium oxide functionalized biochar using dried stem Vigna mungo by pyrolyzing at high temperature. We firstly develop a biochar by using dried stem, and simultaneously we also synthesized our nano zirconium, which is a green synthesis by using the leaf extract of the same plant. And after the development of our biochar, by pyrolyzing it, we functionalized it with nano zirconium. And after the development of our biochar, we characterized it by using SEM, EDX, and XRD PZC in order to identify its physicochemical property, which can be helpful for to understand the possible mechanism involved in the defluoridation. So after that, we performed batch method. This is a lab scale experimental method. We performed it to optimize the adsorptive efficiency of our adsorbent on the basis of pH, initial concentration, contact time, biomass doses. And additionally, we also did equilibrium isothermal study as well as kinetic study from the obtained data to understand the possible mechanism that has been taken place on the surface of adsorbent. So here is the flow chart which is describing our synthesis of our material and its analysis for our defluoridation. We firstly develop our biochar, and after that we performed the surface characterization. And after surface characterization, we performed batch adsorption studies and collecting the data. After collecting the data, we also did its modeling by isothermal kinetic. So this is the result of our characterization. We here we can see that it is a SEM and EDX result. The irregular pattern of the surface of the adsorbent explains that it is very helpful. It is beneficial to provide high surface area for adsorption of fluoride. And in EDX, we can see that there is a clear spectra of zirconium, which indicates a successful establishment of zirconium oxide on the adsorbent. Here is the result of XRD and PZC. So according to XRD, it was found that the our adsorbent is crystalline in nature, with which is correspond to the JCPDS number 88.22903. And we also performed the PZC analysis. Here we found that the surface charge is around 7. That is very helpful to optimize our result at neutral pH. So here is the result of effect of pH and initial concentration. We performed a comparative study. First one is for control, that is unmodified, and second one is with the modified, that is zirconium oxide imprinted agricultural biomass based biochar. We can see that the our result is perform after we get a very good result with the enhanced adsorptive capacity with modification. When we increase the pH, we got the high adsorption efficiency at around neutral pH, and after the increasing the pH, that is alkaline nature, we found there is a decrease in adsorption efficiency. It might be due to the high concentration of hydroxyl ion that might compete with the fluoride ion for adsorption. And in initial concentration, similarly, we found that the on increasing the concentration of adsorbate, the adsorption efficiency decreases. Here is the result of effect of biomass and contact time. We found that if we increase in both the cases, if we increase the dose of biomass, we found high adsorption efficiency, which is around 98.5%. And similarly, with contact time, we in both the cases we found the equilibrium contact time around 60 minutes, where the equilibrium adsorption efficiency reached in both the cases. So this is the result of adsorption isotherm. Here we found that the Langmuir isotherm is best fitted in both the cases. However, the higher adsorption capacity was found in case of zirconium oxide imprinted agricultural biomass, which is 89.78 milligram per gram, in comparison to the unmodified, which is 55.23 milligram per gram, though it is also very effective for removal of fluoride ion from water bodies. Similarly, we performed Freundlich isotherm. Here we found that it is less in proximation with the data, which clearly indicate that the Freundlich model is less applicable as in comparison to Langmuir model, which indicates that the adsorption process might be a monolayer adsorption on the surface of the adsorbent. So here is the adsorption kinetic study. We performed pseudo first order and pseudo second order. So in both the cases in control as well as in modified adsorbent, we found that pseudo second order is best suited for adsorption with a high adsorption capacity, which is in close proximity with the obtained theoretical data, which support the chemisorption nature of the adsorption for fluoride ion on the surface of our developed adsorbent. So in conclusion, I want to conclude that the developed zirconium oxide imprinted agricultural biomass is better in comparison to unmodified adsorbent for the removal of fluoride ion from water bodies. It has high adsorption capacity, which is 89.78. Since it is a low cost, eco-friendly and sustainable method, it can be applied for lab scale as well as industrial scale for the removal of fluoride ion from contaminated water bodies. Thank you for